Imagine your brain trying to remember things, where you placed your keys, the name of that person you just met, or the steps to solve a puzzle. Just like the brain, a computer's memory is a critical storage space that holds all the information and instructions needed to keep it running smoothly. Explanation of memory's role. The memory unit is where the computer stores and retrieves both the data and instructions currently being executed. Whether it's a test document you are working on or a complex video game rendering graphics in real time, memory makes sure the processor has quick access to everything it needs. Introduction of binary system. All data in a computer's memory is stored as a sequence of zeros and ones, following the binary numbering system. Imagine every piece of information broken down into tiny on or off signals. This is how the computer represents and manipulates data behind the scenes. Random access memory. The computer uses a special technique called random access, meaning it can retrieve any piece of information directly without needing to search through everything first, like skipping to a specific chapter in a book. This is why it's called random access memory or RAM. RAM ensures quick and efficient data retrieval, keeping your system responsive and fast. Importance of RAM in performance. With memory acting as your computer's workspace, it's clear why having more RAM can speed up performance, whether you are multitasking or running memory-intensive programs. In the end, just like you need a sharp memory for day-to-day tasks, a computer relies on RAM to operate efficiently. Detailed characteristics of RAM. Firstly, RAM divides the memory into fixed size units called cells. Each cell has a unique address. Think of each address as a number ranging from 0 up to the system's maximum value. Now, let's take a closer look at two fundamental memory operations: fetching and storing data. Let's start with fetch. When we fetch data, we are retrieving the contents of memory cell at a specific address. This is a non-destructive operation, meaning the original data remains unchanged. Now, let's move to the store operation. This one's a bit different. When we store a new value into a cell, we overwrite whatever was there before. This is a destructive operation. Now we can check the key characteristics of memory and registers. In random access memory, the time to perform fetch or store is the same for all addresses. The memory unit also includes two important registers: the memory address register and the memory data register. Now we can check fetch and store steps with this memory address register and memory data register. Let's start with fetch. The store operation follows a similar pattern, but with a twist. This intricate dance between the memory address register and memory data register allows computer systems to handle data dynamically, performing millions of fetch and store operations per second.